One of the coolest things I've discovered about circuits is circuitry can be an art form. Like if I have a creative idea, I can get that creative idea out using circuits. So if you have ideas, you can use technology to make those ideas come to life. Every input or output of a computer is effectively a type of information, which can be represented by on or off electrical signals, or ones and zeros. In order to process the information that comes in as input and to make the information that's output, a computer needs to modify and combine the input signals. To do this, a computer uses millions of teeny electronic components, which come together to form circuits.
Let's take a closer look at how circuits can modify and process information that's represented in ones and zeros. This is an incredibly simple circuit. It takes an electrical signal, on or off, and it flips it. So if the signal you give it is a 1, the circuit gives you a 0. And if you give the circuit a 0, it gives you a 1. The signal that goes in is not the same as the signal that comes out, and so we call this circuit not.
More complicated circuits can take multiple signals and combine them and give you a different result. In this example, a circuit will take 2 electrical signals. Now, each one might be a 1 or a 0. If either of the signals coming in is a 0, then the result is also a 0. This circuit will only give you a 1 if the first signal and the second signal are both a 1, and so we call the circuit AND. There are many small circuits like this that perform simple logical calculations. By connecting these circuits together, we can make more complex circuits that perform more complex calculations. For example, you can make a circuit that adds 2 bits together, called an adder. This circuit takes in 2 individual bits, each one a 1 or a 0, and adds them together to calculate the sum. The sum can be 0 plus 0 equals 0, 0 plus 1 equals 1, or 1 plus 1 equals 2. You need 2 wires coming out because it can take up to 2 binary digits to represent the sum. Once you have a single adder for adding 2 bits of information, you can put together multiples of these adder circuits side by side to add together much larger numbers.
For example, here's how an 8-bit adder adds the numbers 25 and 50. Each number is represented using 8 bits, resulting in 16 different electrical signals that go into the circuit. The circuit for an 8-bit adder has lots of little adders inside of it, which together calculate the sum. Different electrical circuits can perform other simple calculations like subtraction or multiplication. In fact, all the information processing your computer does is just lots and lots of small, simple operations put together. Each individual operation done by a computer is so simple, it could be done by a human, but these circuits inside computers are way faster.
Back in the day, these circuits were big and clunky, and an 8-bit adder could be as big as a fridge, and it would take minutes for them to perform a simple calculation. Today, computer circuits are microscopic in size and way faster. Well, why are smaller computers also faster?
Well, because the smaller the circuit is, the less distance the electrical signal has to go. Electricity moves at just about the speed of light, which is why modern circuits can perform billions of calculations per second.
So, whether you're playing a game, recording a video, or exploring the cosmos, everything you could possibly do with technology requires lots of information to be processed extremely quickly. Underneath all this complexity is just lots of teeny little circuits that turn binary signals into websites, videos, music, and games. These circuits can even help us decode DNA to diagnose and cure disease. So, what would you like to do with all these circuits?